Bill's law, right-hand rule number 1. If current is going up and magnetic flux is to the right, force is coming out of the board. If current is going down and magnetic flux is to the right, force will be going into the board. If current is going up, magnetic flux is going to the left, then force will be coming out of the board. If current is going down, magnetic flux is to the left, then force will be going into the board. Lorenz's law, right-hand rule number 2. If current is in a counterclockwise direction, then the magnetic flux will be up. If current is in a clockwise direction, the magnetic flux will be going down. Gauss's law of magnetism. Magnetic flux travels in the North Pole to the South Pole direction. Parallel DC motor, also known as a shunt motor. The armature coil is in parallel to a field coil, which is in parallel with a source. The armature coil is a coil of wire. The field coil was a coil of wire around a bolt. The source was a battery. Lorenz's law, right-hand rule number 2. As current was going in a counterclockwise direction, it induced a magnetic flux going up. Gauss's law of magnetism. This created a magnet within the bolt. Bill's law, right-hand rule number 1. Since the current is going to the right through the armature coil, and the magnetic flux is pointing upwards, the force is coming out of the board. This induces a spin on the armature coil. This is my construction of the parallel DC motor. With the battery in this direction, the current flows through this wire into this screw across both coils. Now I wrapped the bolt in the counterclockwise direction, so magnetic flux is pointing up. With this, you can see that the current is going to the right, magnetic flux is going up, and so the force is coming out. This will make it spin in the counterclockwise direction because the bottom half of the coil is closer to the bolt and the magnetic flux is stronger in the bottom half of the coil. So the force is applied more on this bottom half of the coil than on the top half, which is why the force makes it spin in this direction and not the other direction. Now if I switch the direction of the battery, now the current is moving in this direction through the coils. This means that the current is now going in a clockwise direction and magnetic flux is going down. But with this, you can see that as the current is flowing the opposite direction, magnetic flux is down, the force will still be pointed out, and so it will still induce the same spin.